All right, number one, right off the bat. Okay, so I'm assuming most people didn't. I should print out a sheet on which ones people missed and go over them. I should do that. Yes, indeed. I'll do that next time. I can print out a sheet that tells me which ones were missed most. Then I would know which ones you guys want to talk about the most. Anyway, number one's probably pretty easy for most people. I would think that probably wasn't a heavily missed one unless you just missed a sign or something little, you know. So x squared is supposed to plug into x squared minus 4yz. You know what, maybe I should, let me do this. That's just, rather than write on the top of the thing and make it all messy. Here, let's get a blank sheet. Yeah. So here's the practice exam. Number 2, and you guys have them in front of you, so you don't need me to put them on the main screen. So x squared minus 4yz, x is negative 4, y is 3, z is 5. Let's plug them in, and off they go, and go from there. All right, so just plug them in, boom, 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 right? And remember, when you plug into a formula, parentheses around the thing, you plug in, right? So I'll stick parentheses around this, parentheses around this, parentheses around this, and pop it in for x, pop it in for y, pop it in for z. Negative 4 squared minus 4 times 3 times 5. Good to there so far. Negative 4 squared. Is that negative in the game? Yeah, so he's going to obey the coach. That means 2 negative signs means positive, right? Positive or just regular 16. Minus, and then what is that? 60? So 60 minus 16, some big number, negative 44. So that was option A. Well, you have all the answers before you. Yeah.
I keep getting some negative 76 on my calculator. I plugged everything in.
Yeah.
See how it is. And
Did you remember to put the parentheses around the negative 4?
let me see. No.
Yeah, so that's it. So you've got to have the parentheses around that. Otherwise, if you just put it in like this, the calculator will say that's negative 16, which it would be. Everybody see the difference in that rule? Because then it's just the 4 squared, not the minus. And it would stay negative, and the calculator knows that and will make it negative. Those matter. Parentheses around those plugins. Good question. All right, we good on that? On to number 2. Number 2. Now this one I think is probably harder, of more interest to people. 3x to the 5th over x cubed. Yeah, I'm glad you're bringing your calculator. I hope everybody's doing that, and whatever calculator you're going to use for tomorrow, right? You wouldn't want to show up, use your cell phone today. I know sometimes you might forget, but it'd be a lot more beneficial to use the real thing, right? I wouldn't want to show up at the ball game with a different glove all of a sudden or a different pair of cleats. Want to practice with what you're going to use, right? All right. So how do you do this kind of thing? Well, first off, why don't we just combine the top, combine the bottom? There's a lot of ways you could go. I'll just combine the top, combine the bottom. How about? So remember, when you multiply on the top, out front numbers multiply, powers add, right? So 5 times 3 is 15. 6 and 5 add to be 11. On the bottom, 3 and 3 make 6. Good so far, and then we'll subtract the powers. Everybody see that so far? So when you multiply on the top, numbers in the front multiply, powers add, right? And now, when they're vertical, so that's for side by side. Powers that are side by side add. 6 and 5 added. 3 and 3 added. Because they're side by side. And the powers that are vertical subtract, huh? So 15x to the 5th. Hey, what if the x to the 6th was on the top and the 11th was on the bottom? What would have happened?
It would have been a minus.
No, x will stay.
Over x.
X to the 5th would have been on the bottom. Because the bigger power would have been in the bottom. But the 15 still would have stayed up top. Because he's like, I'm up top. I'm not going to the bottom. A lot of people I've seen all kinds of various mistakes in that situation, though. That wasn't the problem, but there probably will be one, or very likely on the test like that. So is everybody good with that? Remember, wherever the higher stuff is, that's where the answer ends up, right?
That's the complete answer right there?
Well, no, that's not really. I changed the question all of a sudden at the end. Yeah, let me put it back the way it was. I'm just doing a what if there. So really it was, what was it, 11 over 6. So the higher stuff was in the top. So the answer just stays like that in the top. Nothing goes to the bottom. That's it. Because all the higher stuff was in the top. Yeah, Alex.
Can you show me if you had just combined the x cubed on the bottom times x cubed? you combine those and then separated them into two fractions, how that would go?
Yeah, so you mean like if you just did these two separate and these two separate?
Yes.
Yeah, you can do that. Subtract the powers, this would be 5x to the
Well,
third.
Sorry, I first combined both x cubes.
Okay.
And then I separated the two fractions.
Oh, no. Okay, I see. That's a big no-no. I don't mean to talk to you like a toddler, but that's a big no-no, yeah, because they're not added in the top. That's the difference. So in other words, you can't take one denominator and separate for things multiplied. That's for added. So in other words, if you had, because there's not two things up top. There's one thing. If you had 5x to the 6th plus 3x to the 5th over, like you saying you made it x to the 6th right away.
Yeah.
And then you said, okay, now I just made it x to the 6th here and x to the 6th there. That's okay for plus or minus on the top, because then you really have two things on the top. But because the top does not have plus or minus, you can't separate it into two. It's one thing. So many rules, huh? All these.
Yeah.
That's good though, Alex. That's exactly the kind of questions I asked and I learned. Yeah, it's all these weird little picky rules. So, one thing, especially as we move forward, a deeper important thing that Alex is hitting on there, that when you have things times, it's one term. If you have things plus or minus, that separates, and then we do all the separating kind of steps we do for plus and minus. Plus and minus is what makes algebra hard. All the tricky rules are involving plus and minus. They separate. Question?
I wonder if you can go over the steps real quick.
This one again, yeah, I keep changing the problem. Yeah, let me go back to the way it was here. So what we really did is we did the top together to be 15x to the 11th, we did the bottom together to be x to the 6th.
So you added the 6 and the 5?
Exactly. So you multiply the numbers in the front, the 5 and the 3. They multiply, but the powers add. That's right. Out front numbers multiply, powers add. Really, really important rule. You're right on the money, Stephen. Exactly it.
What if you had one negative power?
Out front numbers, just a second. Out front numbers multiply,
Oh, yeah.
powers add. So out front numbers multiply, powers add. Yeah, if I had a negative power, I'd let it jump to the other side. Negative powers always are unhappy. They hate their job. They want to jump to the other side of the fraction bar. Then they're happy. Then they're positive. So we never leave negative powers, not even for a second. They're unhappy, jump them right away. Negative powers will jump. Negative powers, not negatives on the base level. Two different worlds, right? Power players, base levels. Two different set of rules. Negative powers, jump. Yeah, then we subtract the powers. 15x to the 5th. Good, let's keep going. Number 3. X over 5y to the minus 4. All right. What rule we work with here?
You're multiplying outside parentheses.
Good. Exactly, Jose. Powers outside parentheses multiply powers inside parentheses. Powers outside parentheses multiply powers inside parentheses. Now, what I'm talking about, what are the powers? And I don't see any powers inside the parentheses. What powers are in here? The invisible one, and that's not all. A lot of people stop there and think that's all there is. What am I missing? Even the 5, even numbers have an invisible 1 power. Yeah, everything has its own 1 power, if it doesn't have some other power already showing. Now, the negative 4 goes boom, 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 hits all 3. Powers with powers. Senators go to lunch with senators, right? Governors with governors. They don't go to lunch with me, right? Powers with powers, not with bases, right? That minus 4 is not going to multiply to 5. No, that's beneath him. That 5 is just a base. No way. It's going to multiply the power, right? Powers with powers. Powers interact with other powers in the power world, right? All right, so what do we got? X to the minus 4, 5 to the minus 4, y to the minus 4. Good so far. That minus 4 just multiplied all 3 of those ones. Right, the invisible 1 powers. Now, we got some unhappy campers up there. We got some unhappy powers. Negative powers, what are they going to do? Going to jump. And the whole fraction will flip effectively, huh?
Yes.
Because they're all unhappy. If everybody's unhappy, everybody's trading jobs, right? So this will go up, this will go up, this will go down. And after they're jumped, then they're happy. So 5 to the 4th, y to the 4th. They're positive afterwards, right? X to the 4th, and there we go. Or maybe they want you to do the number. Oh yeah, looking at the multiple choice answers, they're all like 625. So they must want you to take that 5 and go 5 times 5 times 5 times 5 in your calculator. Yeah, that is 625, isn't it? So it's 625 y to the 4th. You can guess that without even doing it because it's on all the multiple choice answers. So there's the answer.
I think it's easier to flip it than make the exponent positive and then.
You can totally do that. Just flip it in the beginning. And then the power is positive because that's what the negative power is going to do. Yeah, nice thinking.
That's what I forgot to do.
Is the flip, the jump? Yeah, negative powers always want to jump to the other side.
And then I just looked right now too, it even tells us exponent, a positive exponent.
Oh yeah, you're right. Yeah, right. Yeah, and that'll be, not only now, next class for that. Always, you never leave negative powers. They always jump. Good on that. Shall we go on to number 4? I think we can squeeze number 4 in right here. So x to the 9th. Good. I like this time. This feels like the most learning that happens is when you've tried something and you know what you know and you know what you need to practice, and we're able to get right to the business. All right. So what's the deal on this one?
You're dividing them, so you're subtracting.
Subtracting powers, right? Whenever they're vertical, we subtract. If they're side by side, we add. They're vertical, we subtract, right? So, and where's the answer always end up?
Where the highest number is.
Where the bigger one is, right? So when it comes to the x's, who's got the bigger one? The top, so they subtract 4 on the top. When it comes to the y's, who's got the bigger one? Bottom, so they subtract, and the 6, y to the 6 is on the bottom, huh? Everybody see that? When it comes to the z's, who's got the bigger one? Top, they subtract, the z's second. Good like that. So the y bigger one was on the bottom. That's why the y ends up on the bottom. Wherever the bigger is, that's where the answer ends up. All positive, because I'm always starting with the bigger one in those subtractions. Right? Does everybody see why those are all positive powers? Because I always started with the bigger. Like on the x's, I started with 9 minus 5. The y's, I started with the bottom 9 minus 3. So that way you always get positive powers and you're just done. It's nice, quick. Good on number 4. To number 5 we go. So the number 5 to, let's see, 5 squared. Is that a plus 20? Divided by minus 9. Okay. Where do we go first? Parentheses. So what's that? 25 plus 20, so that's 45. Okay, and so now we multiply 2 times 45. Excuse me. 90 divided by minus 9 minus 10. Good. Probably can just type it all into your calculator. Number 6. Stop me if you have questions. I'm going to go quicker on these ones I think are easier for you, but something weird's hanging you up, let me know. Because it's probably more than just you. Other people have the same questions usually. All right, let's try that one. So what should we do first? Then we can do that power. 9 squared is 81, huh? And then multiply these guys plus 49. Am I going too quick there? So I did the 9 squared, 9 times 9, 81. Choose your calculator. And then I multiplied negative times negative, 2 negatives, 7 times 7, 49. And then add them up, 120, 133. And there we go. Was that a none of the above?
Yes.
Oh, was that disturbing? No, you guys are comfortable now, huh? You're like, I know sometimes it's none of the above.
No, I try and sit there and like I just look through A and D and I forget about E, so I keep thinking I'm wrong.
Oh,
I'm
so,
trying to find-
so you eventually just take a guess?
I draw.
You eventually just take a guess at one of them after a while?
I'm like trying to get
Well,
everybody.
and then I remember that there's an E.
Oh, okay. It dawns on you eventually.
Yeah.
Yeah. No, there will be some E answers. 3 or 4 or 5. I don't know how many on the next test. There's a few E's. There's not 10 of them. You don't want to get 10 of them. But there's a few. All right, let's keep moving. Number 7. So 24x to the 7th minus 12x to the 5th over minus 4. So now this is our quiz question that we started with today. right? So we're getting it from the practice exam. Now, notice on the top, pluses and minuses. What does that mean? Two separate things on the top. So this is the kind you break into two separate fractions. Like we were talking about Alex's question earlier, right? See the difference? On this one in the top, you got pluses and minuses. So that's two separate terms. You break it into two separate fractions. Getting the hang of all those rules? All right, so we did this on the quiz, so I'll just do it quick here. We divide 24 over -4. I hope y'all got this one since we had it on the quiz today, and then I went over it.
So if that was, if it was a positive in, like.
If there's a plus in the middle here,
Yeah.
yeah, then it would be a plus in the middle here. Because whatever's in the middle up here becomes the middle of the two fractions. It's just this guy just becomes denominator for both of them.
So you would still break it up into like two parts?
Yeah, I would still, plus or minus, either way, would still break into two. The time when it wouldn't, maybe I should be more clear on that, is if they were timesed. That's a 12 or whatever, like that. Then that would not be two separate fractions. Because they're times, they're just one thing on the top. That's one. What would you do then? What we did a minute ago on this. I'd multiply the numbers in the front. 24 times 12, I think it's 288. Add the powers. Then I would divide these and subtract the powers. So you'd get what? X to the 5th on the top. What are those numbers? I don't know. 72. I think it's minus 72. Something like that. Keeping it one fraction the whole way. See the difference? If they were times on the top. Does everybody see that? So that's a different problem. I hope I'm not confused by doing two problems at the same time. If they were times on the top, like we had a minute ago, that was number 2. Question number 2. Right, look back at question 2. They were times on the top. So that would not be broken into two fractions. That's one. Just multiply the numbers in the front, add the powers, right? And then subtract the powers and divide the numbers. Done. Whereas this one is two terms. Yeah, terms is the key word. Terms are things separated by pluses and minuses. So up here we have two separated terms. What are the separators in math? What are the commas that separate, or the periods, or whatever you want? In the grammar language of algebra, what separates one thing from the other? Pluses and minuses. Adding and subtracting, not times. Adding and subtracting. So you want to look at it that way as you're looking at an algebra problem. You want to think, oh, one term, separator, another term. Pluses and minuses separate. They're like commas in English is, right? They serve that role. Okay, so with that separator there, then we have two separate fractions, really. So we have this fraction and this fraction. There's no plus there. Two separate. Okay, now we divide them in front. 24 divided by minus 4 is minus 6. And the x to the 7th just cancel out. Two minuses, like we talked about in the quiz, plus. Divide them, 4 goes into 12 3 times. The 3's on the top, but the x to the 2's on the bottom because the bigger power's on the bottom. Right? The bigger power's on the bottom, the bigger out front number's on the top. So the out front answer ends up on the top, the power answer ends up on the bottom. Because of where the bigger thing is. Everybody see that? 12 is bigger than 4. So when you divide them, the 3 ends up on the top, but 7 is bigger than 5, so when you subtract them, the 2 power ends up on the bottom. Question, Stephen, question?
No, I just realized it turned positive because it was two,
Yep, those two. And it doesn't matter where they're at, bottom, top, front, whatever, they get together. Two minuses make plus. Right? It doesn't matter in a fraction if you're in the top or the bottom or the front, it's all the same world. Two minuses is plus. All right, number 8. Ooh, that's a big ugly one. So number 8. 9y squared z plus 4 y to the 4th z to the 6th minus 12 y to the 3rd z to the 3rd all over 3 y to the 3rd z to the 5th. Okay. So Do we have more than one term in the top?
Yes.
Yeah, those are 3 separate terms. Why? Because of the separators. See the plus and the minus? Those are separating into 1, 2, 3 separate terms on the top, huh? Pluses and minuses are like commas. They separate. So you can make that into 3 separate fractions, right? 9y squared z over 3y cubed z to the 5th plus 4y to the 4th z to the 6th over 3y cubed z to the 5th minus 12y to the 3rd z to the 3rd over 3y to the 3rd z to the 5th. See what's happened there? I just separated into 3. Like that. Same denominator, right? Why? Because he was the bottom for all 3. And now just do 3 separate problems. What do? You divide the numbers, subtract the powers. 3 goes into 9 3 times, subtract the powers. So the 9 was bigger than the 3. That's on the top. So when you divide them, 3 goes into 9 3 times, ends up on the top. But when it comes to the y powers, where's the bigger one? Top or bottom? Bottom. So y to the 1, or just y, is on the bottom. Where's the bigger z? Top or bottom? Bottom. Now what's the z power on the top? I see no power on the z on the top. 1. 5 minus 1 is z to the 4 on the bottom. Good so far down there? Plus, now the middle one. Yeah, the 4 and the 3, they can't divide. 3 doesn't go into 4, so just leave them. Just leave the 4 on the top, leave the 3 in the bottom, nothing more they can do. How about the power stuff? y4 minus y. Where's the bigger y power, top or bottom? Top, so y to the 1, or just y on the top there. And what about the z's? Where's the bigger z power? Top, so z to the 1, or just z on the top. So 4, y to the 1, z to the 1, or 4yz over 3. Huh? Everybody see that? Minus. Now, 3 goes into 12 4 times. Y's totally cancel. Z, the bigger one's on the bottom. Z2 on the bottom. And we're done. This making sense? It'll be points tomorrow. You'll nail it and get points tomorrow for this. It's cash tomorrow.
Is the
Points.
one-
Yeah.
All I missed was the power for the 1 minus 5.
Oh, right.
Everything else I got right, but for some reason I didn't minus the 5.
The one, oh, I see. You just kind of look up and go, there's nothing here, so it's just 5.
Yeah.
Yeah, those invisible ones, they're everywhere, aren't they? 5 minus 1.
I
Yeah.
didn't know what to do with the 4 and the 3.
Oh, yeah, it's confusing, because normally they all cancel, huh? We haven't had too many that don't actually cancel at all.
Uh-huh.
So they just stay there like that. It's kind of weird. Yeah, I don't remember too many that have done that.
No, I didn't.
Yeah, I had to look at the answers.
Yeah, sometimes that helps. You kind of look and you go, oh, they're leaving
I was
them.
like, you can't divide that.
Yeah, so this is weird. And you're like, oh, yeah, okay, they didn't divide it.
And
Good.
they want us to write out a whole string of decimal
This is a test. This is a test hammer. It really is a test hammer.
Okay.
Sure, Amber appreciates.
All right, good with that? Shall we move on to number 9? T to the minus 3 over t to the minus 6. Yeah, negative powers are unhappy. They're negative. Where they're at, they're going to jump. Both are. Now, what if only one of them was negative and one of them was positive?
They'll join together.
Yeah, the positive one would stay put, and the negative one would jump.
Test. This is a test hammer. It really is a test hammer.
Okay. That's the Amber Alert thing? Is that what that is? Anyway, all right, so both the negative ones jump, then I jumped them, and then they become positive after the jump. That's always first. Don't subtract first. Don't do anything else. First, let them jump. First, negative powers jump. They're unhappy. Let them get happy first. Let them jump. Okay, so now they're happy. Now they've jumped. Now what do? Do we add them or subtract them? Subtract, because they're vertical. If they were side by side, I would add them. If they're vertical, I subtract them. Now, where's the answer going to end up? Is the final answer going to be in the top, or is it going to be in the bottom? Because the bigger one's in the top, the final answer is in the top. But if it was like this, if it was if the bigger one was on the bottom after they jumped, after they were positive, then it would be 1 over t to the third, right? Wherever the bigger one is, that's where the answer ends up. If the bigger was on the bottom, the answer would end up on the bottom. But we had the top, so the answer ends up on the top. When I call that top, it's really over 1. We don't show that, but it is. That's why we call it top, right? Anything written alone is really in the top, is really over 1. Good. Questions on that one? Number 10. Minus 2x to the minus 6. Okay, so what rule will we follow here? What's the rule? Powers outside parentheses multiply powers inside. Who does the governor take to lunch? Regular people like me? Powers with powers. Powers hang with powers, right? So that negative 6 is going to multiply the 1 and the 1. The invisible 1 powers, huh? Okay, so we're going to get... Now, oh, and also, what about this minus in the front here? Well, let me hold that a minute. So it'll be this. So far, so good? Let me just do that first off. Right? Powers outside parentheses multiply powers inside parentheses. Now, those are both negative powers. What do negative powers do? I'm not caring about this minus yet. I'll get there in a minute. I'm just saying this is a negative power, and that's saying, what do negative powers always do? Jump. So this guy's going down, this guy's going down. So we get minus 2 to the plus. Just the power becomes positive, not this. Just the power. We're only doing powers right now. The other one will become positive in a minute for a totally different reason. Right now, it's just powers that have become positive, right? Negative powers jump to the other side. And there's nothing left on the top, so that we just put a 1, huh? Final step. So, and sometimes they leave it like this, don't they? Sometimes they leave it like this. If you look on the test, there's no parentheses. The answers, there's no parentheses. So you go, oh, okay. What's going to happen to this minus 2 to the 6th? Is it minus? Or is it plus? How do you know? 6 minus signs. Plus, or regular. It's plus, or just regular. Because 6 minus signs, right? This means 6 minus, this is minus 2, minus 2, minus 2, minus 2, minus 2, minus 6 of them. So 6 minuses, plus.
So even though you haven't written it all, solved for 2 to the 6, negative 2 to the 6, you still change the sign in front of it?
Sometimes. So they can do all kinds of different ways. This is a true answer. This is a true answer. What would that be, 64? Yes. This is a true answer. All 3 of those are right. It's just a matter of the look they gave it. They so happened on this problem to give it that look. Yes, you have to know what's true in different formats.
So then the answer wouldn't be negative 1 over 2, it wouldn't be 8?
No, there's no negative. Right? The negative end. There was a negative in the parentheses.
Yeah.
But on answer A, they've removed the parentheses.
So
No,
that's why you change it.
Yeah, if they're removing the parentheses, they let the water go in.
Okay.
So they let down the floodgates. The water's not just going to sit there like in the cartoons in a big wall of water. It's going in, right? So if they lower the floodgate, 6 is going to do his thing. 6 minus signs, plus. No minuses anywhere, top, bottom, front. That's all the same thing, top, bottom, front. So if there was a minus here, yeah, you could put it, but there is no minus anymore because I'm simply looking that they lowered the floodgate. Sometimes they leave it this way. They leave the floodgates up and the thing on there. Then that's fine. Sometimes they lower them, and you got to know how to correctly lower them. Sometimes they work out the number. Sometimes they don't. Does that make sense? Got other questions? Yeah.
Okay, so
Melissa.
1 goes because they all jumped?
Yes, because there was nothing left on the top. Because they all jumped, and there was nothing left. Yeah, whenever everybody leaves the top and it goes down to the bottom, we have to have a 1.
And then the negative in the front represents that all the signs are going to be changed, so it's going to be a positive, right?
That's it, yeah, because it really means 6 negative 2s. Exactly right. 4,
The answer
5,
must be.
6. Is it? I don't.
No, it's none?
No, yeah, because you have to have.
Because it turned into a fraction.
Yeah, it's got to be a
The
fraction.
other one on top.
Gotta have the one on the top.
I got that it turned into a positive from the two to the power of 6.
6, yeah,
Because
good.
it was a positive or an even number.
Even, because it's even, exactly.
But I forgot about the flipping.
Yeah, negative powers jump to the bottom, and if there's nothing left on the top, that means a 1. Yeah, the reason B would be wrong, is if I just write 2 to the 6 x to the 6 without any fraction at all, it really means over 1. Are you aware of that? And that's upside down. Anything you write without being a fraction really is a fraction over 1, really is in the top, and that's not correct. Our stuff needs to be in the bottom on that. Other questions? Stephen?
I think I got confused just because, like, it's not a fraction.
I know, originally it's not. And you're like, how can it become a fraction? Because everybody jumped. Yeah. So remember, negative powers make them a fraction.
Yeah.
They jump, and then they're a fraction. Yeah, that's exactly what negative powers do. They jump to the other side, leaving nothing on the top, so then the top's a 1. Good there? Making sense? These rules coming together better? See how this time's important now, because you've studied all these things, you've done every one of these problems, and it was just last week, right? We cranked through all of them, but there's a difference when you mix them all in. So remember this as you go forward, whoever your next math teacher is, or whatever down the line, this is what you need to do for you. If they don't do this for you, you need to do this for yourself. You need to spend time on that practice. It's different than homework, huh? It's the mixing together. That mixing together is real important. All right, let's keep moving. Where are we at? That was number 10, so number 11. So number 10 was a good learning exercise. That was not one that was very comfortable at first. All right, so what do we do on that one? Powers outside, multiply powers inside, right? The governor goes on for the governor. Powers with powers. So power outside, multiply power inside. Y to the minus 15. And we don't leave negative powers. What does that do? Flips it to the bottom. Makes it a fraction. And then the power becomes positive or just normal. Question, Melissa?
About the last question, so had that all been positives, it would have been, would it just been the 2, 6?
If that would have been a positive 6 power?
The one before that you did.
Yeah, number 10 right there?
Yeah.
Yeah. If that had been a positive 6 power, if it had
Everything
been,
was positive on there.
if everything was positive, like just 2x to the 6, yeah, it would have been just 2 to the 6, x to the 6.
Okay.
Yeah, wouldn't have made a fraction at all. Yep, you're right. It's that negative that made it jump to the bottom and become a fraction. Exactly. Negatives jump to the other side. Be okay with this one? So again, there it is again. Negative power jumps to the bottom, becomes a fraction, huh?
Yes, sir.
All right. Let's go to number 12. 3 over 7 to the negative 2. Here we go again. Powers. Outside. Parentheses. Multiply. Powers. Inside. Powers the powers. Governors the governors, right? So that minus 2 is not going to multiply the 3 and the 7. It's going to multiply the invisible 1 powers on the 3 and the 7, right? Powers with powers. So what do we got? 3 to the minus 2 over 7 to the minus 2. Good so far. Negative powers? Jump. Jumping up, jumping down. 7 to the positive 2 over 3 to positive 2, which is what? 49 ninths. 49 ninths. Positive 49 ninths, right? Good there. Does that make sense what happened? So the power up here multiplied the powers, and then they jumped and became positive after the jump. Good. How we doing? We're doing well. Okay, we're about halfway. How many questions do we have? 25, about halfway through? All right. Can I move on? Number 13. Number 13. So, minus 3m.
This is a test.
Not again.
This is a test hammer. It really is a test hammer.
Probably
Yeah, because he says it's so similarly, huh?
What if that's an emergency or something?
Emergency alert, right. That's if a child is taken, is that what that is? Amber alert? Is that what that is? All right, so, and there's a lot of police on campus. Have you noticed that this last semester? They upped it. This is one of the safest places in town now. There seems to be a police officer on every corner. All right, so we're multiplying those two parentheses, right? Because their parentheses are right up against each other. So that means multiply. So how do we do this? We
Test. This is a test.
This is an interruption. All right, multiply the numbers in the front, add the powers, right? All right, so minus 3 times positive 3 minus 9. And add those powers. 3 and 4 make 7. 4 and 2 make 6. Add the powers, yeah. Multiply the numbers in the front, add the powers. Yeah, right there. Multiply numbers in front, add powers. This will be up on YouTube later if you want to look back at any of this. Just get ready for tomorrow's test.
You know what I could not find on YouTube and I kept looking and looking was for 2.7.5.
Yeah,
Yeah, it was not up there.
It was not on there and I was just like, oh my god.
One of them's not up there?
yeah, it was like the ending of 2.7.
Yeah. It was like 2.7 and it said 5.
Yes. I did something bad. In class, yeah. I went back to my office too and kept searching for it. No, it's just gonzo. I don't know if you remember, but at one point I clicked something funny. You know, I'm bad with technology. Yeah, I just erased it into oblivion, I guess. Yeah, it's funny. You guys are tracking close. I'm impressed. Yeah, I thought, oh, probably nobody's even looking. They won't notice. You guys are all, where is that?
That's the one that you kind of need to have.
Oh, shoot. Is it? Oh, well, that's when I goofed it up. Yeah. I erased it. I erased like the first half of that day. And then suddenly it picks up in 2.8, huh?
Yeah.
Yeah, no, that's all gonzo. I'm sorry, it went into Never Never Land in the tech. It's
Yeah, I kept on going back and forth, back and forth, back and forth.
there's
I
something
seen it
missing.
in my notes. I'm like, it's in my notes. Like we did it. I'm like,
Yeah, it happened, right? It did, but it's not in the memory
and then
banks.
The example on the problem is just it was just shooting like the answer on that part, and it's just
It doesn't really,
confusing.
yeah, it doesn't
Yeah.
explain it as much.
At all.
Yeah, like on one of those problems, or
Yeah, if you put in help or whatever for that particular problem.
oh, the show me an example. It just shows it. It doesn't explain it. Gotcha. Yeah. Sometimes it's so. Yeah, come to Mr. Roberto if you want to work through any of those. He will be there. But also now, like if, we're kind of going over those again now. So please speak up if I can help in any way. Hopefully that won't happen again. Yeah, it's funny. I spent like maybe half an hour trying to recoup it in my office, searching on this thing, and I went, no, it's just gone. I searched everywhere I could. But I comforted myself with probably nobody's even looking. But that's not true, which I'm glad. I mean, I'm glad you guys are.
so you did number 13. Right?
Yeah, we did 13. We good? Multiply the numbers in the front, add the powers. Okay. Now there's that adding, subtracting, which means there's two terms on the inside, right? There's one term in the front, two terms on the inside. I just want to help you to start knowing how you look at the big picture of algebra things, right? Pluses and minuses separate. So one term in the front, one thing in the front, two things on the inside, right? One term in the front, two terms on the inside. What happens in this case? I just multiply and multiply. Right? That one thing in the front multiplies each of the two on the inside. See how we always do that when we have pluses and minuses? Even, let me go back for a second. Even as let's get kind of the big picture here. Even as you, where is it? It's back a ways. Divide. Look back at number 7. See how we had two things on the top with a dividing fraction? Well, then it's like distributing with dividing. We put the divided for each of them. If that minus 4x to the 7th had been in the front with parentheses, I would multiply both of them. But it's going to be two problems, is my point. In both cases, when you have things separated by pluses and minuses, that's two terms, which means you're going to do two whatevers. If it's dividing, you'll do two dividings. If it's multiplying, you'll do two multiplies. It's two problems in one. Plus, and we're going to get heavy into that next week, probably next week, I think. Maybe the end of this week, or next week for sure, where we have the big messy ones. No, I'm exaggerating. No. I'm jumping into Math 201 already. No, we're not gonna go too crazy. Math 201, we'll go crazy on all. We'll have lots of terms. You wanna distinguish one term from many terms. There's a lot more talk about that at that time. All right, anyway, where are we at? I'm getting lost. There we are. So we have two multiplications.
Trying to scare us.
That's right. Wah, it's scary. All right, so multiply both those on the inside. What happens when you multiply? The numbers in the front multiply, powers add, right? Numbers in front multiply, powers add. So 6 times 3 is 18. Powers, what's the x to the 4? Y to the what? 3. Yeah, because there's the invisible 1. Always there, lurking. Minus. 6 times 6 is 36. 1 and 2 makes 3. 1 and 3 makes 4. There we go. Are we happy?
So you did both?
I did them both. Yeah, so that 1 in the front went to both. And when he did, the out front numbers multiplied, the numbers in the front multiply, and powers add. So the 6 multiplied the 3, and the 2 and the 2 added to be 4, and the 1 and the 2 added to be 3. Like that. Out front numbers multiply, powers add.
I think I got confused. I was like thinking about doing what's in parentheses.
Oh, yeah, I see what you're saying. Good question. Yeah, we can't do what's in parentheses. Yeah, we have to multiply the one thing from the outside to both. On that one.
Can you go one step forward and solve that?
What's that?
Can you?
Do one more step?
Yes.
Good question. To answer it, let me ask you a question. So the question is, can we subtract these now?
Yes.
Right? Good question. Really good question. Can we subtract? So remember, we can multiply anything. So I multiplied the first step, anything. But adding, subtracting, we can't add, subtract anything. Remember, adding, subtracting is picky. All the picky rules throughout this class and the next two classes all are about adding, subtracting. You can only add or subtract, not anything, but only like terms. They have to be exactly the same letter pattern. And they're not. They're different.
And that would have only affected the base number.
That would have only done the number in the front, the base number, right? Exactly. In that case. Yeah, so we can't go any further because their letter patterns are different. So you can multiply or divide anything, but you can only add, subtract like terms. Same letter patterns on that. So many rules, huh?
So little time.
So little time, 4 weeks.
Sorry, because I have the power.
All right, good, you do. You can do this. If you've got the time to put in, I think you can practice and practice and practice and get this down. All right, 11y plus x and 11y minus x. Okay, so that's two terms of two terms, FOIL, right? Or first to both, second to both, however you want to think about it. So as we multiply, what's the rule? Out front numbers multiply, powers add. So here we go. So I'm going to take 11y times 11y, and then 11y times minus x. So that 11y in the front is going to multiply both of the two in the back. When it does, the out front numbers will multiply the powers will add. So 11 times 11, 121. The invisible 1, y to the 2. Good so far? 11 times 11 and 1 plus 1. Minus, because this is a minus x times a positive 11y. Minus 11xy. He's done. His turn's over. He's gone to both the other two. Now, it's the x's turn. He's going to go to both the other two. So here we go. X times 11y, well, that's plus 11xy. It's plus because it's a positive x. And then plus x times minus x squared. The invisible 1 powers add. Good, good, good. Bye-bye in the middle, right? So 121y squared minus x squared. Done. Are we good there? Questions on that one?
We went the scenic route on that one.
Did I? Or you did?
No, you did.
Did I?
That's the scenic route.
Let's see. Did you just know they're going to cancel in the middle and just skip it? Yeah, you could do that. If you've seen enough of these, you know where this trip is going. All right, number 16. Number 16, minus 5x plus 8 minus 4x plus 10. Two terms with two terms. So what do we do with two terms with two terms? Same thing we did last time, right? First to both, second to both. All right, here we go. So this first one will go to both. Minus 5x times minus 4x. Negative times negative? Positive 20x squared, right? The invisible 1 powers add. Good. And negative 5x times plus 10 minus 50x. And that one's done. Good so far. So he's done. Now it's the 8's turn. The plus 8's going to go to both. So plus 8, boom, boom. Minus 32x plus 80.
There's a lot of, none of the above.
What's that?
There's a lot of, there's none of them.
Oh, is there another? Is this another above? Let's see. So 20x squared. Now multiplying's over, right? This was the multiplying step. It's over. Now we're on the adding, subtracting step because the parentheses are gone, right? Parentheses are gone, right? Whenever you multiply from the outside of parentheses, multiply two parentheses together, they're gone. You're in adding, subtracting mode now. And so our whole thinking, the set of rules changes. Adding, subtracting rules are always different than multiplying rules. So now I'm going to do like terms. Add, subtract, only like terms, only numbers in the front. Oops, I'm getting scribbly there. Oh, right. Yeah. Let me write that. You're right. Not powers. Exactly. You don't mess with the powers when you're adding, subtracting. You only do the numbers in the front. Right on. The only time we mess with powers is when we're multiplying or dividing. Multiplying, we add the powers. Dividing, we subtract the powers. But if you're adding or subtracting terms, it's only like terms and don't mess with the powers, right? So these two are like terms, minus 82x. And I don't make it x squared, I just leave it x. Good? Rules all coming together.
So how would you know not to use the exponent to like the 32x or 20x? You see the 20x.
So I'm saying we do not go 1 power makes 2. We don't do that. Because we're adding, subtracting here, not multiplying. You only do the power stuff when you're multiplying. Like on step 1, when I did this times this, I did add the 1 powers to get 2. Make sense? So when you're multiplying, that's when you mess with the powers. When you're adding, subtracting, you don't fiddle with the powers at all. Just leave it plain x. Just do the numbers in the front.
And that's why it stayed negative instead of changing it to negative to a positive.
Yeah, that also. 2 negatives make a positive only when you're multiplying. Not adding, subtracting. They just make a bigger loss, right? If you lose $50 and you lose $32.
Parked alongside westbound McKinley will be towed within the next hour due to construction. If you're parked in that area, please move your vehicle immediately. And all vehicles parked alongside Fresno City College on westbound McKinley will be towed within the next hour due to construction. Thank you. Bye-bye.
Wow.
Where are these?
Westbound McKinley.
Yeah, westbound.
Out on the street.
Right. Talk about the street. So here's Blackstone and McKinley. What's right here, huh? So I'll write McKinley over here. So they're talking about cars right here. So here's FCC. Talking about cars right here will be towed, right? Am I getting that right?
Yeah. They said westbound, so that's probably only on the
This way.
westbound side of the street. So that's, it's not on this side of
Well, yeah, it's the ones next to city, not the ones over here on this side of the street. So there's the street. It's the cars that are parked here,
It's where they
not
have
the cars parked
It's
here.
where they have the signs.
Yeah,
They have
it's
signs.
these cars that are parked next to city, that are west.
Yeah,
Yeah.
'cause as of today, I think that's gonna be closed.
Yeah.
We can't
Right.
park that.
Jose, is that where you're at, man?
Yeah,
No.
going
Oh,
westbound.
okay.
Going westbound is the one that's
So
closed.
feel free to run out if your car is parked next to City College on McKinley. They did that on my street, my little residential street today too. They put all these signs out, you know that, where they're, Tuesday, we're gonna da-da-da-da. So I was texting all the kids, last night, don't park your car on the street, it will be towed. Daddy doesn't pay, you know, on a clear text, that's your baby, right? Don't park it, they're like, okay, Dad, we'll remember, park them down the street.
Yeah, that's 5 kids, that's exponential.
Well, they don't all drive, but, well, 3 of them do though, yeah. All right, so, yeah, the little ones, no problem. Anyway, we good there? That all making sense? Shall we move on? We got 15 minutes, gotta beat that clock. That was 16? On to 17 we go. Minus 7 to the 0. Minus 7 to the 0. And then as we got into bed, too, my wife says, so you did move my car, right? It's not in the garage? I went, oh, that's right. 'Cause I moved one of the kids' cars. And I just thought I'd moved all the cars. So we're in bed, laying in bed, and she goes, you did move my car, right? Out of the garage down the street? Like, that's what I say. So, honey, did you want to just go get it and I'll lay here? Right? Isn't that the role of the husband? Just lay? No. No. So I walked down the street and moved the car. It was my fault. Anyway, 0 powers. 0 powers. All right, yeah, anything to the 0 power is 1, right? Anything to the 0 power is 1. So this is to the 0 power 1 minus, and then this is 1. Now, you might wonder, where'd that minus go? Well, is this minus here in the game?
Yes.
Yes. Is this minus in the game? No, this guy's just watching. So he's for sure staying. He's just sitting on the side watching the game. He doesn't care what the coach says, right? But this minus here, he's in the game. He's going to obey the coach. And what does Coach 0 say? You're a 1. So that minus vanishes and becomes a 1. A regular, normal, positive 1. Everybody see the difference? The minus in the middle stays because he's not in the game. He's not in the parentheses or anything. So the final answer, 0. Everybody see that? So when the minus is in the parentheses, it obeys the coach, like always. And the 0 coach says you become a 1.
Even if it's minus.
Even if it's minus. If you have negative, whatever that is, 73,816 to the 0, the whole thing's positive, regular, 1. But if the negative was here with no parentheses, then this minus says, I'm not listening to that coach, I'm just watching. And then this part becomes 1, so it'd be negative 1. Everybody see the difference? So negative, that's why I'm saying you're just a spectator if you're not in the parentheses. You're not doing anything the power says. Unless you're in the parentheses, then you obey the coach. And it becomes a 1. Right, good. All is well. All right, 18. Should we move on with 18? Two x minus 5y squared. 2x minus 5y squared. So, what parentheses with the 2 power. So what do you do when you've got the 2 power on the parentheses? 2 of them. You got to write actually 2 of them. Right? Don't make the mistake of just thinking you can square. Really, really, really common mistake. My daughters made it for a year before they learned it. I must have said it to them 100 times. So 2 parentheses, right? You got to write 2 parentheses. Then FOIL. When you have a 2 on the parentheses, you got to write 2 of them. And then just do the distribution thing. Yeah, so the 2x is going to go to both. When he's done, the minus 5y will go to both. Remember that? Okay, so here we go. Now, as they multiply, remember, out front numbers multiply. Powers add. So 2x times 2x. 4x squared, right? The invisible 1 powers are always there. Minus 2 times 5 be 10. They're multiplying, right? Yeah. So actually 2 times 5 is 10. Xy. Oh, gotcha. So does that make sense so far? So now the 2x is done. He's had his turn. He multiplied both out front numbers multiplied, powers add. Now it's the minus 5y's turn. He's going to go to both minus 10xy plus 25y squared. Good to there. And 2y it's plus, because minus 5 and minus 5, two minuses make plus. And the invisible 1 powers add to be y squared. Now, the middle two are, now I'm in adding subtracting mode. The multiplying is over, no more parentheses, I'm in adding subtracting mode. The middle two are like terms, aren't they? So we can combine them. Minus 10 and minus 10 is minus 20. xy, don't make it squared or anything. You never mess with powers. When you're adding subtracting, only the numbers in the front. There we go.
They don't cancel out, they're both negative.
Yeah, right. If one was negative, one was positive, then they would cancel. You're right. Good, exactly, Jeremy. But if both are negative, they just, you lose $10, you lost $20.
And if that was a negative in front of the beginning of the problem 2x, would all those symbols still change to? Or no?
If there was a, yeah, right. If there was a negative on the 2x, it would carry through.
And the same thing as if the power was a negative on the top, it would change.
Well, negative power is a jump. So that'd be, they would give you negative powers in this situation. But yeah.
At least not yet, huh?
Right. Yeah, there's always more, huh? Not in this class. Good on that. Onward we go. Number 19. X times x to the minus 6. All right, what do we do? What do negative powers always do? This guy's jumping down. Now the other one has an invisible 1 and he's happy. It's a positive 1. He's staying put, right? He'll stay up there. But the other one jumps to the bottom and then becomes positive after the jump, right? He's unhappy. But the x to the 1 just stays on the top. And then what do we do with those powers from there? Subtract. Where's the answer going to end up? Bottom, because the bigger one's on the bottom. Everybody seeing that? Bigger one's on the bottom. All right, so bigger one's on the bottom, smaller one's on, and just a 1 on the top, not x to the 1. Everybody seeing that? Yeah, so what happened there is, just think, let me give this, what if you had x to the 2 over x to the 10th? It's kind of weird there's a 1 on the top, so let me change to this. What would you do in this case? You would subtract the powers, x to the 8th on the bottom, right? 10 minus 2 is 8. Now, you're not just going to leave it like that with nothing on the top, huh? You always, whenever everything's gone, you just put a 1, right? That's what I'm doing here. I'm just going 6 minus 1 is 5. And there's nothing on the top anymore, so I put a 1. Same kind of thing, because the bigger one was on the bottom. So the answer ends up on the bottom. Therefore, nothing's on the top, but we put a 1.
So when they multiply, or no, and it's supposed to flip or not?
Well, I did that already. This negative power, he jumped to the bottom. Yeah, so that's already done. See, they're both positive at this point. Both the powers are positive at this point. So I'm just subtracting them. And whenever you subtract, the answer will end up wherever the bigger one is. I'm going to close with a clicker. I mean, feel free to do whatever you want, but we will end class with a little clicker quiz at the end of every meeting, so don't want to surprise anybody. All right, so you're going to subtract those powers on that.
No, I viewed them as two different fractions, so I put x over 1.
Times 1 over x to the 6th, and cancel, you can totally do that. That's great. There's another way. Is this good? Is this making sense? So negative powers jump, and then we subtract powers.
It worked out for me this time, but could you just simply subtract the negative 6?
You could, and then jump it.
Okay.
That's good too. We good with that? Does that make sense on that? Whenever we subtract, the answer ends up where the bigger one is, in this case the bottom, and when there's nothing left on the top, you put a 1. All right, let's keep moving. We're going to make it through here to number 20. Number 20, 4a to the minus 4, b to the second to the minus 2. Okay, what's the rule on number 20?
Powers have to multiply.
Yeah, that's right. powers outside, parentheses, multiply, powers inside, parentheses, yeah. So let's do it. And so what powers into this has invisible 1? Don't forget about that invisible 1 on the 4. So boom and a boom and a boom. So we get 4 to the minus 2, a to the plus 8, b to the minus 4. We're not done yet, but so far so good. The power on the outside just multiplied all the powers, including the invisible 1 on the inside. Now, the negative powers, they're unhappy. What are they going to do? Going to jump. So this guy's going down, this guy's going down. The a to the 8th, though, he's like, I'm happy. I'm staying put. So the a to the 8th stays in the top. The 4 to the plus 2 and b to the plus 4 go to the bottom. And then they become positive, right? The unhappy powers become happy, positive, after they jump. Now, I could leave it that way. Oh, no, they made it 16. They went ahead and made that 4 squared into 16, didn't they? 4 times 4. And this is a b. So it's 16 on the bottom, 4 squared. Is that good? Did that want me to show a separate step there? So this is 4 to the plus 2, and so that's a to the 8th over 16b to the 4th. This is a b. Does that make sense on that? Questions I can answer?
So no one left one power on there and then they just worked out the other one? Or?
Yeah, because this is just numbers, not letters. Yeah, so the number ones we work out. If that was like a W to the second or something, I just leave it. But if it's a number, you can just do it on your calculator. 4 times 4 becomes 16. But the letters we leave. Is that good? 20. 5 more. 21. So this is just numbers, huh? 4. 22 minus 14 over 2 plus 6 squared minus 2, 37 minus 6. So this is just work out the numbers. Where do we start? You know, parentheses. So that'd be 50 minus 4. What's that? 6, 7, 8. 8 there. This is 8 squared. This is what? 31. So I did the parentheses first. And then what's last? Adding, subtracting. Just remember, adding, subtracting is last. You'll be okay. So notice, don't go 50 minus 4. Go 4 times 8 is 32. 8 squared, 64. 2 times 31, 62. And then subtract that. What's that? 18. Is that 2? 9. I'll move on. 22. 22. 6x. This one looks messy. Oops. 2x squared plus 3x minus 4 plus 2 parenthesis 2x squared plus 3x minus 4. All right. Yeah, that's a little messy. You want me to multiply all that, huh? That's just like a lot of multiplying and adding and everything. So this 6x got to go boom, boom, boom to all 3. 6x to all 3 of those guys. And what's the rule when you multiply? Outside numbers multiply, powers add, right? And don't forget about anybody that doesn't have a power has an invisible 1 power. So 6x times 2x squared is 12x to the 3rd. Plus 18x to the 2nd minus 24x. Good so far? Plus, now this 2 will go to all 3, huh? Boom, boom, boom. 4x squared plus 6x minus a. All the parentheses are gone. Now I'm in adding, subtracting mode. Like terms. And just the numbers in the front, don't mess with powers, huh? Now, everybody good to there so far? Now, 12x cubed, he's in a class by himself, nobody like him. And then 18x squared and 4x squared, those are like terms. 22x squared, I don't mess with powers, just numbers in the front. Minus 24x plus 6x is minus 18x minus 8. Good on that one. 3 more. You ready for more? Can I move on from that? 23. Another FOIL. 5x plus 6. 5x minus 10. All right. So the 5x goes to both. You know the deal here, right? When they multiply, out front numbers multiply, powers add. 5x times 5x, 25x squared, because the invisible 1 powers add. Boy, it's getting messy on me. I'm writing it messy. Minus 50x. He's done. Now, the plus 6 goes to both. Plus 30x minus 60. Okay, these two in the middle. Minus 20x. There we go. That good? Questions on that one? Number 24. Moving on to the end here. 10p minus 1. Oh, this is a messy one. 100p squared plus 10p plus 1. So here we go. 2 terms times 3 terms. So the 10p goes boom, boom, boom to all 3. 10p going to multiply all 3. What's the rule when you're multiplying? Out front numbers multiply, powers add. So put the invisible 1 powers on those 2 p's. And here we go. 10 times 100 is 1,000 p to the 3rd. Plus, now this guy with this guy, 100 p to the 2nd. And then this guy times 1 plus 10p, done. Good so far. And now the minus 1 is going to go to all 3. Minus 100p squared minus 10p minus 1. That minus 1 just multiplied all 3, changing all the signs. Yeah, now we're in adding, subtracting mode, right? Now I do add, subtract, because it says subtract. Because multiplying is over. So this guy comes first. He's in a class by himself. Then 100p squared and minus 100p, they cancel. 10p minus 10p, oh yeah, just minus 1, huh? That's nice.
At least the answer's simple.
The answer, yeah, bunch of mess in the middle. Is that good? Getting the hang of all that FOIL. One more, huh? 25. 3a cubed x minus y squared, parentheses, 9y minus 4x squared. X is minus 2, y is 3, a is minus 1. So you know what you do, parentheses, parentheses, parentheses. Plug them in, plug them in, plug them in, right? So I'm just going to do it quick. A is minus 4, x is minus 2. Y is 3, 9 times 3, minus 4 times minus 2 squared, like that. So there we go. Now what do we do first? Parentheses, go here. 3 times 9 is 27, minus 4 times 4. Is that okay? Minus 2 squared become plus 4? Do this parenthesis, what is that, 64? Negative. Thank you, yeah, I was forgetting the sign. Try that again. Minus 64, right? Because of the negative to the 3rd power. Odd amount of negatives, good. 3 squared is 9, huh? Let's finish these parentheses here. 27 minus 16. Oops, too many minuses. This is a messy problem. A lot of signs and parentheses. Okay, and here we go. So subtract those, was it 11? And then multiply these guys, I don't know, something really big.
123, 128 times 3, so 384.
positive, and it's positive, huh, because there's two negatives, right? Everybody see the two negatives? Positive. So 384 minus 99, which is take away 100, add 1, so 285. There it is. Is that answer on there? Yes, it was B, which is always reassuring after all that work, huh? Instead of a none of the above. Well, that was a lot of work. Tomorrow's the real deal. Practice all that. Let me, oh, wait a minute. What am I doing? I'm getting all messed up. Right. So we're supposed to be beginning and ending with a clicker quiz. And so we're out of time today. So I'm just going to do it quick. It's just going to be a freebie quiz. That's so often what I do at the end of class. Channel 41, it's on. Click A. A for Apple. You got a free quiz, 10 points. Don't click a different letter. I mean, you can click A again if you accidentally. So it's just a free because we're out of time. I don't want to hold you anymore. Click A for Apple. I often in class with a free click because I always run out of time, it feels like. A for Apple, and you got your points, and you're done. Free clicker quiz. All right.